ವಿದ್ಯಾರ್ಥಿಗಳೆಲ್ಲ ನನ್ನ ಸ್ನೇಹಿತರಿಗೆ ಸೋದರಿಗೆ ನಮಸ್ಕಾರ. Guys, today I'm going to do the continuation of digital design and computer architecture, which I already taught the first 1A question, which was there in your model question paper, and it is officially announced VTU model question paper, guys. We expect minimum number of questions which are going to come from your official model question paper. It might be the same or else it will be of the same pattern, okay, but the concept will be definitely useful if you guys learn it. And the last session which I taught you guys is about a NOR gate or a NAND gate, which is not a associative but it will be a commutative. I already taught you how to prove it. So if they ask even about NAND gate, you guys should be able to do it. I have already given you the sign convention. Just use that sign convention and just show them it is not associative. Okay. And now coming towards the next question from the particular model question paper, that is 1B. Okay. The question is about to design a car safety alarm circuit. Keep it in mind, guys. We are going to design a car safety alarm circuit. Okay. Our main intention is to design a car safety alarm. Means car safety in the sense what? If anything happens or if the conditions, preconditions are not met related to the safety, if you go and give a dash, if the door is not closed, if the seat belt is not fastened, or you have not kept the key but you are going to start the vehicle. So these are the some safety aspects which we are going to take care. But there will be some conditions in this particular question. Let us see for what conditions we have to generate an alarm. Okay, let us see the question in detail. The system considers 4 inputs. See, they are already mentioning here there are 4 inputs. What are the 4 inputs? See, the one is the door, and there is a key, and there is a seat pressure, and the another one is the seat belt. So let me put in the given data first. Okay, let me put the given data. In the given data, we are designing what? We are designing car safety alarm circuit. Okay, we are designing the car safety alarm circuit. In this designing aspect, our main concern is about the 4 inputs. There are 4 inputs which are given in the already the question. The inputs are, one is the door is treated as D, and the another is the key is designated as K, and there is a seat pressure which is treated as P, and there is a belt which is treated as B. Okay, these are the 4 inputs. Inputs in the sense, in order to tell you guys, for any alarm to be generated or any output function to happen, you need a control circuit. You need a control circuit. It might be PLC, it might be microcontroller, it might be microprocessor also. This control circuit might be. For this, today we are going to connect 4 inputs, that is door, key, seat pressure, and a belt. These are the 4 sensors. We are giving a feedback of the sensors to the control circuit. Based on the internal programming, we are going to generate an alarm. Is our today's task. In the car design, in the car safety alarm circuit, we have 4 inputs. These are treated as 4 input sensors. The sensors are going to give the feedback to the control circuit, which generates an alarm. But for what condition an alarm to be generated, let us see in detail. See, the input is considered high. See, now they are talking about when the input is high. When you treat door as high, key as high, pressure as high, when you can say that the belt is high, means if the door is closed, means high in the sense it is activated. High in the sense it is activated. Okay. For activation, they have given as 1. Let us put for what conditions they are saying is as 1. Okay. Inputs are high or 1 for what conditions? Let us see it. Okay. First condition, if the door is closed. See, if the door is closed, the input is high. Keep it in mind. Okay. And the key is in. Okay, and the key is in. Door is closed, key is in, and the driver is there on the seat. If the driver is on the seat, it will sense some pressure. Yes, some guy is sitting on the seat. Under the seat, there will be a pressure sensor. Okay, this pressure sensor will be activated and it will give us high output. Okay, so if the driver is on the seat, then it is treated as high. And if the seat belt is fastened, means if you have put your seat belt after sitting on the seat, okay, seat belt is fastened. FASTENAD. Okay, if the seat belt is fastened, these are the four conditions. You treat it as a high, but you also should know when it is low. It's simple, opposite of this. When the inputs are low, guys, you guys only can analyze. When the door is open, when the key is not in, when the key is not in, when the driver is not in the seat, nobody in the seat, nobody on seat, and belt is not fastened, means you have not put the belt, not put the belt, but you want to drive the car. These are the issues, right? If you have not put the belt, it is a safety action. Always you have to put your safety belt while driving, or else you are sitting idle in the car. Okay, so now let us see for what condition an alarm to be generated. The alarm should sound with the two conditions as stated below. See, there are two conditions for which the alarm should sound. Should sound in the sense, for alarm is actually a speaker. Is actually a speaker. This is also a type of a device, right? See, for inputs also we are using four devices, and for output also we have to use some device to give alarm, right? So in this case, alarm is generated on two conditions. Okay, and which device is giving an alarm? The speaker is giving an alarm. Okay, let us see the two conditions. Two conditions. What are those two conditions? The first condition, I will write it here. Okay, the first condition. First condition is the door is not closed and the key is in. Means when an alarm is being generated, for the first condition, the alarm should sound. For the first condition is when the door is open and the key is in the, you have already put the key in and the door is open. See, this is an unsafe act, right? So if you just clearly visualize the given question, okay, you are into the car, you have already put your key in and you have not closed your door, then it is a safety issue. So what you have to do, you have to generate an alarm. So that is why this is the first condition. And the second condition is what? Second condition is the door is closed, the key is in the driver's seat and the seat belt is not closed. Okay, the key is in the driver's seat and the seat belt is not closed. Here also there is one particular pattern. See, the door is closed. Okay, the door is closed and the key is in the driver's seat. The key is in the driver's seat and the seat belt is not closed. Okay, the seat belt, what happened? The seat belt is not closed. The seat belt is not closed in the sense you have not put your seat belt. Okay, you have not put your what? It is seat belt. Not put your seat belt. No, no belt. So Now we will convert it into a logical one. See, when we have to put low, when the door is open, right? I will put here as low. When the key is in, it is nothing but high. You put it high here. When the door is closed, it is treated as high. When the key is in, it is treated as 1. And when the belt is not put, it is treated as 0. So these are the two conditions. Okay. Now what they're asking, construct a truth table for the system based on the input arrangement DKPB with A as the output. This is the first question. So let us go to the first question. 1B of A. First question. See, I have already drawn the truth table. It is a decimal form. It is a decimal form from 0 to 15. Why I have taken until 16? It is simple. We are having 4 inputs. It is nothing but n is nothing but how many? 4 bits. So total number of operations will be 2 power n, which is nothing but 2 power 4, which is nothing but 16 operations you have to get. That is the reason we have to put for 4 inputs. It will be of a 2 power 4. Okay. 2 power 4 in the sense the decimal form from starting from 0 until 15 you have to put and write down their equivalent binary numbers in the DKPB format. This is the table of 0 to 15. Then when an alarm is generated, guys, this is the very important one. Means already we listed the two conditions. Let us see the first condition. The first condition was when the door is open and the key is in, right? Then an alarm should be generated, which is nothing but an alarm should be activated, means it should be high when the door is open and the key is closed, key is in. And the second condition is was when the door is closed, in the sense it is high and the key is in the driver seat and the belt is open, means you have not put the belt. This is also an unsafe act. So you are already into the car. Okay, you have the key in and the door is also closed. These both are safe acts. If the door is closed and the key is in, okay, safe. But belt is not put, means this is a different scenario. Okay, this is also an unsafe act. These both are treated as unsafe act. Okay, unsafe act. So that is why we have to design a circuit to generate an alarm. So we will now what we will do is we will put an alarm high for these cases. Okay, let us put 1 for the first condition. When the door is open and the key is in, means wherever the door is 0 and the key is 1, you put it as straight away 1. Door is 0. See here all door is 0, but key is not 1, right? See, for these 4 cases, door is open and the key is high. These 4 cases are unsafe conditions. So you just put it here as 1, 1, 1 and 1. Simple. Okay, now what we are doing, we are just designing a truth table. Okay, and the second condition is when the door is closed, okay, and the key is also in, but when the door is closed, key is in, but the belt is what? Belt is not put. One minute, guys, I will be back. So guys, so The second condition is saying about when the door is closed, key is in, but belt is not put. No belt means it is 0. So for all the condition of 1, 1 and 0, where D is 1, K is 1 and B is 0, you put it as high. Where this condition appears, see, D, K should be 1, 1. These are the 4 conditions where D and K is 1, 1, but B should be 0. That is a very important point. The D is 0, the B is 0 in this condition and in this condition. For these both cases also it is treated as 1. So now the rest all is treated as zeros. Keep it in mind. Okay, rest all are treated as zeros. Okay, so the first question of this particular 1B session we have fulfilled. See, construct a truth table for the system based on the input arrangement DKPB with A as output. So this one we have fulfilled because we have constructed a truth table. This is the truth. This is called as truth table. Okay. This is called as truth table. We have constructed it very clearly for all these both conditions put together. According to the conditions, we have designed our truth table. Okay, well, this is well and fine. And let us go to the next question. What they are asking. The next question is about design a Karnaugh map to verify the simplified expression. Design what? Design a Karnaugh map to verify the simplified expression. Karnaugh map is possible. Karnaugh is nothing but K map is possible only when we are having a truth table. We should have a truth table to draw a K map or Karnaugh map. So what is the truth table we are having? This is the truth table we are having. Now going towards the next question, that is 1B of C. Okay, 1B of 1B of B. Okay, 1B of B. Where this is 1B is the main heading question. In that there is a B question. To draw the K map. Draw the K map to verify the simplified expression. To verify the simplified expression. Okay. K map to verify the simplified expression. Okay, let us see how to do this. See, to draw a K map, we are having to draw a K map. Sorry, guys, 1 minute. So to draw a K map, we are having how many inputs? 4 inputs, right? For 4 inputs, how many cells we will get? Totally 16 cells. Simple, right? You draw 4 cross 4 truth table. This is called as 4 cross 4 K map. Okay, 4 cross 4 K map. Okay. What are the outputs? Inputs we are having D, K, P and B, right? You write it as here. DK in the left hand side, right hand side the PB. You can write anything as possible. Huh? It is not a problem, but go according with your truth table. It becomes helpful. So DK means now I will draw the K map according to the truth table. So in order to draw the according to the truth table, what is the function we have to follow? To draw a SOP function, to put a SOP function, it is simplified sum of product form, a sum of product form. To draw a SOP function, we will go according to the truth table, that is D bar K bar. So or else you can write it as 0 0 0 1 1 0 and 1 1, and here also you can write it as 0 0 0 1 1 0 and 1 1. This is the standard form, guys, you have to follow. In the decimal, if you put like 0 1 2 3 0 1 2 3 like this. Okay, so this is nobody will going to teach you, but the thing is how to draw this table is very important. Okay, Hope you guys understood this table. According to this table, you can put the numbers. If you multiply this both, what it will happen? 0, 0, 0, 0. What it will happen? Here it is 0. 0, 0, 0, 1. What it will give? It will give you 1. 0, 0, 0, 1 is 1. 0, 0, 1, 1, it is nothing but 3. See here, 0, 0, 1, 1 is what? Decimal format is 3. And 0, 0, 1, 0, where it comes? 0, 0, 0, 0, 1, 0. It is nothing but what? 2, right? Here you put it as 2. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. This is how you are going to draw the two table. So now wherever there is 0 and 0, put bar, okay? Put that particular letter as bar, okay? 0, 0 means it is nothing but here we are using two variables, that is d and k. So put d bar and k bar. Here it is 0, 1 is nothing but put as a d bar for 0 and put k for 1. And where it is 1, 1, you put it as d and k. And where it is 1, 0, put it as for 1 it is k d, and for 0 it is k bar. Wherever it is 0, 0, put bar. That's it. Okay. Here we are using pb, right? For 0, 0 means pb means just it is p bar and b bar. And here it is p bar and b. Here it is pb. Here it is p and b bar. Simple. Okay. Now what we are going to do is put ones wherever we are seeing that particular fashion. For 4, 5, 6, 7, there is 1, 1, 1. Put wherever 4, 5, 6, 7 is there, 1, 1. 4, 5, 6 and 7. You put it as 1, okay. And 1, 1 is for 12 and 14. You put it as 1 and 1. Where 12 and 14, you put it as 1 and 1. This is what about K-map. That's it. You have drawn the K-map. But to verify the simplified expression means first you have to bring out the expression for this. How to bring out the expression? There is a condition. You all guys are very well known about this. Condition is after drawing the K-map, you have to follow 4 rules. One is singles. Singles are, you call it as, it is not forming grouping with anyone. So these are called as groupings. Single grouping you can do, or pair grouping you can do. It is twos, and you can do the quad grouping, which is fours, and you can do the octs grouping, which is eights, and even you can do the 16 grouping, but which is not possible. Okay, but if you can go up to octs. Okay, so now coming towards here, if you see 1 1 1 1, rest all are treated as zeros, guys. There is no problem, rest all are treated as zeros because it is not mentioned anywhere in the question. Okay, anywhere in the question you can put it as 0 0, but no need to confuse. Don't put anything, just leave it. If they have given any don't care conditions, then you have to put it as a cross mark. For don't cares, we put it as cross mark in that particular cell of the K map. Okay, now coming back towards the grouping. Here you can see either you can do row wise grouping or the column wise grouping, not a problem, row or column wise. If you see once all the rows or all the columns, you can do grouping. If you see 2 and 2, anywhere you can do the grouping. See here, but go with the maximum. First check for 8 groupings, oct groupings. Is there any oct grouping in the particular cell? If there would have been here 1 and 1, then it would have been an oct group, because it would have formed a 8. But here there is no 1 1 in the 13 and 15 cell, so we cannot form oct group anywhere in of the K map, anywhere of this particular K map. But let us check for quads. Go always with the highest, come towards the lowest. Okay, if you going to check the quad, you can form quad in this particular questionnaire by using these 4 in the row wise. See, this forms one quad. Even if it is row also not a problem, even if it is column also not a problem, but there should be a 4 4 of grouping, or even it might be a rectangle, that is also not a problem. Here it have done 1 and 1, then also you can form a quad. Okay, this is the one of the case. And another case is what? You can form one more chord using these both. Or else what I will do, I will use the another pen. You can form one more chord using these both and these both. So considering these both 1 1 and this 1 1, it becomes a 4 of grouping. Okay. And considering all these ones, it becomes a 4 of grouping. So this is enough. No need of considering any again the different types of formats, guys. Okay. So now if you take this as group 1 and if you take this as group 2, then we have to write a expression for this. What is that expression? Simplified expression. You can write the simplified expression. 1 minute. You can write the simplified expression. So you know to write the simplified expression. To write the simplified expression, use this table. One is the prime implicants, and essential number of number of implicants or numbers, means which is not having any grouping with any of the following, or you can call it as singles, and essential prime implicants. You can call it as EPI. Okay, put this as a table. Okay, what are the prime implicants? Prime implicants means you have done two groupings, right? So consider these two. This is a dummy, not there. Now we have done only two groupings, so consider only two rows. So now if you go back to the circuit, if you see the first grouping is about this one, which is in the red. Okay, 1 1 1 1. See accordingly the rows and columns of that particular inputs. Inputs are what? D and K, DK, PB are the inputs. Now watch clearly, these both ones are in the rows of D bar K and DK and P bar B bar. Okay, these both ones are there with are relative with these rows and columns. So now if you consider these both, okay, this both D bar and D get cancel each other in these two rows. Only remains is the K. Okay, only remains is what? The K. In this complete row, okay, in this complete row, if you consider these both ones and these both ones, in these two D bar K and DK, D bar and D get cancelled. Only K remains. You just put it as K here. Okay, for this particular one. And now only row wise we have solved. Now coming towards a column wise. Okay, now coming towards a column wise. P bar B bar for these both ones, and another is a P and B bar. Check for which are alternate or complements. See here, P bar B bar in P bar B bar and PB bar, P bar B bar and PB bar, P and P bar get cancelled, only remains is the B bar. So you write that B bar in here. Simple. So the grouping of first one is the KB bar is the fractor or the expression. Now coming towards the second grouping, that is all ones in these rows. D bar K is the one and only expression. D bar and K is the one and only expression which remains. Because in all of the columns, if you see, all everybody cancels each other. Okay? How? Here P bar B bar, P bar B bar and PB both cancels each other, and here P bar B and PB bar both cancels each other because alternate has to be cancelled. So all the columns will be cancelled for this second grouping, and only remains is the D bar and K that has to be taken. Now if you consider these both in our expression, okay, for the first grouping, what is the expression? For the first grouping, the expression is KB bar. For the first grouping, the expression is KB bar, and for the second grouping, and for the second is D bar and K. D bar and K. Okay. For the first grouping, KB bar. Okay. For the first grouping of KB bar, this is the first grouping, right? In the first grouping of KB bar, which are not mingled with any other groups. The numbers which are not involved with any other groups is this 12 and 14. 12 and 14 are not grouped with the second group. But this one and this one are already grouped with the first group or the second group. See, here there is a common one. Here this one is common for the second group as well as the first group, and this one is common for the second group as well as for the first group. So we will not consider this both the decimal numbers, that is 4 and 6. We have to consider only 12 and 14, which is nothing but here you have to write the 12 and 14 are the essential numbers which are not mingled with any other groups. Similarly, check for the second group. In the second group, the same ones are mingled with two groups, and these two, that is 5 and 6, are not mingled. So just write it down in here, the 5 and 6. So now if you check the essential prime implicants are those which will be the same. Means if there are no essential numbers, okay, if there is no essential numbers, then it will be of a different. If there are essential numbers, then put the same factor. Okay guys, what you can do, you can put the same factor. So these are the both prime implicants or the essential prime implicant. Now to write the expression is nothing but always treated as y. Take this both, that is the group 1 and group 2. Group 1 is KB bar and group 2 what we have got is D bar and K. Take the prime implicants. So this is what your expression. Now to verify the condition, the first condition if you consider and the second condition if you consider. In the first condition, what does it says? Where the door is 0 and the key is 1, right? The first condition. And the second condition is door is closed, key is also in, but belt is not put, that is 0. These are the two unsafe facts. So if you substitute in this above expression, the first condition is KB bar plus D bar and K. Okay, what happens? We will see. Okay, means an alarm should be generated at this particular point. The output is nothing but what? It is alarm. So alarm should be 1 for these two particular cases. So now we are verifying by using this expression, either the alarm will be 1 or no. Okay, put 0 and 1 in this above expression, that is wherever you see D put 0 and K you put 1. K I am putting 1, B bar is not shown, so I am putting B bar. D is 0. For D bar I have to put it as 0, I have to put it as 1, and K is also I have to put it as 1. Okay, I'll just write it. D is 0, right? But for D bar it is complement, which is I have to take it as 1, and K is given as 1. Okay, Now 1 into b bar is nothing but it is b bar according to the Boolean rules. 1 into 1 is it's just 1. Anything that a plus 1 is nothing but 1, which is nothing but b bar plus 1 is nothing but 1. Simple. So which means the alarm is generated by using this expression. Similarly, you can put the second condition also in the same expression, k b bar plus d bar and k. Put d as 1, where k is 1 and b bar, b is 0, k bar is 1, plus d bar means d is 1, d bar is 0, and k is also 1. See, for this also if you put 1 into 1 is 1, plus 0 into 1 is 0, so 1 plus 1 is again 1, which is nothing but the alarm is high for this case as well. Means according to the design of the Karnaugh map, we verified, hence what you can write it as, hence we verified the K map, the alarm is generated. Alarm is generated by using expression, okay? By using expression, simplified expression or just expression you can write it as, okay? So now we have proved the second question as well. And the third is